So what we're going to start off today with is a discussion of some features that have been added to Java after Java 8 that enable it to work, that enable certain things like the Java Completable Futures framework to work with virtual threads. So virtual threads is one of the main focal points of this course. So we're going to show how you can integrate this into the Java Completable Futures framework in a very interesting and cool way. So let's go ahead and take a look at the motivation for this. So when Java 8 came out, which was a while ago, about a decade ago or so, it had some methods that allowed you to specify an executor to run your asynchronous tasks in, such as the supplyAsync method. You could give it the executor you wanted it to use. However, it only handled a certain subset of capabilities provided by the Completable Futures framework. And in particular, you couldn't specify executors for certain operations. You could specify them for some, but not all. And so as a result, some operations would default to running in the common fork join pool, whereas others would run in whatever executor you had defined, which was very confusing and caused you to scratch your head and tear your hair out. I asked ChatGPT to generate a diagram that showed the frustration developers felt because of this inability and limitation with Java 8, and this is what it came up with, which was actually pretty funny. So what they did in Java 9 is they added some new support to make it possible to integrate custom executors consistently and holistically throughout Java Completable Futures. And you can read about the APIs that are involved here. We'll talk about some of them in a second. And as a consequence, what you could do is gain complete control over all the different asynchronous computation steps. And what we're going to do with this is we're going to leverage this capability, which came back in Java 9, which was probably 8 years ago or so. And we're going to use it in order to be able to leverage an even more recent set of capabilities, namely Java Virtual Threads. So with what we're about to show, we're going to show how to integrate Java Virtual Threads into the Completable Futures framework in a much more orderly and coherent way. This is ChatGPT's explanation of, or visualization of how this looks as compared to this. Not always perfect, but it was pretty funny, so I added it. So here are the three methods we're going to focus on. And these are the methods that allow custom executor implementations, such as the ability to use virtual threads. So we're going to start off by talking about the default executor method, which will give back the executor that's to be used for all the operations in Java Completable Futures, not just a handful of them. So this is a method you can override, and we'll see how that works in a second. There's also another method called newIncompleteFuture, which is called back by the framework at certain points in order to get back a new completable future that will be returned by a completion stage method. And we'll talk about what that is in a second. And then the final piece of the puzzle is something called completeAsync, which is a method that was added in order to be able to take a completable future, like one that knows how it's going to be run with virtual threads, and then complete it asynchronously using the supplier that's passed in as a parameter. Now, what's interesting, when you saw the Java 9 definition of these methods and explanation, it really didn't make a whole lot of sense. It was just like, what on earth is going on? So I'm going to show you an example that will help make this much more clear, and it'll demonstrate where things like completeAsync come in handy. So let's take a look at an example, and then we'll walk through the example more broadly. So we're going to define our own completable future subclass. So here we have a class that's called CompletableFutureEx, which extends completable future. You have to override completable future because there's these hook methods that need to be overridden. And we're going to override these things in order to use virtual threads. So there's various ways to do this. One way to do this is to give it an executor that makes a new virtual thread for every time you need a new virtual thread, or you need to run an asynchronous task. There are other ways to do this, which we'll talk about in the next part of the lesson. This is just a very simple way to do it right here. We then override the default executor method to return the default executor. So we gave it a default executor that makes a virtual thread for each new task. That's what's going to be returned whenever default executor is called by the framework. We're then going to define the newIncompleteFuture hook method, which we override, and that's going to return a new instance of CompletableFutureEx, which is this class right here, as opposed to CompletableFuture. And then finally, and this is the most interesting method, we're going to override supplyAsync, which is the factory method that's used in order to execute the task, the supplier task, asynchronously. And we're going to make it make a new instance of CompletableFutureEx, which is the class we're defining, and then we're going to say, hey, finish completing this supplier task using these mechanisms. In other words, using the virtual thread per task executor to run all the operations irrespective of what they do and how they're called, what completion stage method is invoked. So that's the basic design of this. So we're going to take a look at how to use it in the next part of the lesson, but that was just the first part.